All right, we're going to do one more example of similar variety here, factored form because it's got two parentheses. It's a quadratic because there will be an x squared when you multiply it if you take that route. But we're not going to do that. We're going to find the roots in the vertex. And the first root is going to be from the first parenthesis, but the second root is we're going to take a little bit more work to figure it out. So this is a hard example because you can't just instantly look at the numbers, say it's opposite of what we see. So the first root uh, is occurs when this factor x minus 5, if that is 0, then everything will become 0. And if we solve for that, that occurs when x is the number 5. So the first root comes from that first factor. If x is 5 and we plug that in, the whole thing will be equal to 0 because 5 minus 5, this factor is 0. And it doesn't matter that over here this is 11. It doesn't matter that this is a 1/3 in front. The whole thing is multiplication by 0. And so the first root, r1, is 5, 0. And the second root comes from the second factor, this one. We will figure out what value of x would produce 0 for this factor by setting x plus 1 equal to 0 and solving. So 2x equals negative 1, and x is negative half or negative 0.5. It's probably easier to do that as a decimal. So if x equals negative 0.5, then the first parenthesis is something else, but when we multiply 2 times negative 0.5, this factor is now 0, and thus everything will become 0. So the second root, r2, is negative 0.50. All right, so those are the roots. The vertex is next, and that is found in the middle of those two places. Now, just to get an idea of what to expect, make a little sketch here, and I'll call negative 0.5 that spot, and I'll just say this is going to be 5, and I'll make a sketch of what that's going to look like. All right, middle is here. Now, I knew this opened up because this leading coefficient, the 1/3, it is a vertical shrink because this number is less than 1. That makes it a little bit more squished than a normal parabola with a leading coefficient of 1. But since it is a positive number, it's going to open upwards, which is called concave up. If it was negative, it would go the other way. It would be concave downwards. Okay, this spot, the vertex, is halfway in between. So if we add the two x values, 0.5, and we average them by dividing by 2, find a halfway point. That's 4.5 over 2, or 2.25. And so the line of symmetry is at x is 2.25. That is the x of the vertex. Now, if we want to find y, we have to go figure out what that is by plugging in x equals 2.25, and y equals 1/3 2.25 minus 5, 2 times 2.25 plus 1. And if this is a calculator problem, you can just calculate that number. If it is not a calculator problem, then we have to do a little bit more work, which I'll go through the trouble of taking it that route. So 2.25 minus 5, negative 2.75. And then 2 times 2.5, 4.5, 5.5 when we add 1. All right, now I'm not going to multiply these decimals together. If I had to do that without a calculator, that'd be very challenging. Instead, I'm going to convert them into fractions and then multiply. So 5.5 is a little, I recognize that one. That's half of 11. So 11 over 2 is equivalent to 5.5. And negative 2.75, I recognize that as negative 2 3/4. 1/3. Okay, so we are multiplying all these fractions together, but we can't actually do that with a mixed fraction like this. The 2 wholes and the 3/4 is a fraction. We need to convert that into an improper fraction like this one over here, where the numerator exceeds the denominator. So to do that, we're going to multiply these 2 wholes. If we convert that into fourths, that'd be 8/4. And then we'll add that on to the 3/4 that exist. Now that's 2 times 4, 8, plus 3, 11/4. That's negative. And 11/2 and 1/3. Okay, so that's the y value, and then we just need to multiply these fractions, and to multiply them, you just multiply all the numbers on top, negative 121, and multiply all the numbers on bottom, 24. So if the problem had asked for the exact value of the vertex, the y value of the vertex, this would be the necessary fraction. If it's a calculator problem and you just want a decimal approximation, that is the same as negative 5.042. So let's summarize here. That point then is at 2.25, and that's not rounded, so it's okay to leave it like that. And to be accurate, 121/24. That is the vertex. Now again, this problem is in the hard category or harder category because of 2 reasons: the fraction work to get the exact value, and the extra thought necessary to figure out the second root. It's not -1. We have to solve it equal to -0.5 instead.